In this example, let's say that a quantitative analyst for the New York Stock Exchange models the value of Apple in tens of millions of dollars with respect to the number of iPhones in thousands of phones sold in the US by this function. The value is equal to x squared minus 625 divided by x minus 25, where x is the number of cell phones sold. So let's say that Apple wants the value of their company to be 50 plus or minus $0.01 million. Um, I don't know why this is some made up scenario, but let's just, for the whims of the CEO, if their value is at $50 million plus or minus $100,000, what range of iPhone sales would guarantee that this value of Apple occurs? So, like before, what do we want to know? We want to know that V is equal to 50 plus or minus 0.1, or writing this in terms of inequalities, this means that the absolute value of V minus 50 needs to be less than or equal to 0.1. And we want to use this to get a handle on the number of iPhones, X. So the number of iPhones being sold. So let's rewrite it. So that's going to be true if x squared minus 625 all over x minus 25. So that's my V, right? This is my equation for V. So I'm just replacing V with that equation right there. So that's V. So as long as V is minus 50, so minus 50 is less than or equal to 0.1. Well, let's get a handle on what this is. So if I look at this equation, I don't know, couple things. I could either just turn this into one fraction, or I could recognize that the top is a difference of squares. And so the top is x minus 25 times x plus 25 divided by x minus 25 minus 50 is less than or equal to 0.1. And so I get canceling here. So x minus 25, x minus 25, they cancel. And this becomes absolute value of x plus 25 minus 50 is less than or equal to 0.1, which tells me that as long as x minus 25 is less than or equal to 0.1, then this is between, the value of the company will be within 0.1 of 50. And what is this telling me? Oh, as long as it's iPhone sales, so as long as my iPhone sales, as long as x is equal to 25 plus or minus 0.1, then the value of the company will be 50 plus or minus 0.1. And that's our range. So as long as iPhone sales is 25 plus or minus 0.1. Now, a observant student should notice that if I put 25 into here, V of 25 is not even defined by my formula here, because this would be 0, 25 squared is 625, and over 0, undefined. So my analyst should have done a little bit better job in looking at this function and said that V is equal to, piecewise, x squared minus 625 all over x minus 25, as long as x isn't 25, and make it equal to 50 if x does equal 25. And in fact, this function is now continuous because we could take the limit. What is the limit as x approaches 25 of x squared minus 625 all over x minus 25. And we know we're taking a limit, so we're not actually at 25. So I would use that value. And just like we did just a second ago, this is the limit as x approaches 25. The top factors into x minus 25 times x plus 25. The bottom is still x minus 25, which gives our canceling. This is the limit as x approaches 25 of x plus 25, which is 50, which is exactly the value of my function at 25. That means it's continuous at that point. Right? So this would have given us a continuous function, and we would have exactly an evaluation of $50 million if 25,000 phones were sold. But we're told that we just want our evaluation to be within $100,000 of 50 million, right? 0.01 million is 100,000. And so as long as our sales of phones are 25,000 plus or minus 100 phones, then our valuation will be where we want it. So in the next video, I'm going to take these ideas and use it to give us our formal definition that you would have met in a traditional Cal 1 class and how to use it. But the intuition that I've been building here, looking at these estimates, are exactly the intuition that's sitting behind our formal definition. So we'll come back to that in the next video.